Another example here, our final example of the section. We're looking at the series n cubed over natural log of 3 to the n. So right away, let's not be confused by this natural log of 3. It's simply a constant. So let's just treat this like any other constant. So let's apply the ratio test. So limit as n approaches infinity of n plus 1 cubed over ln of 3 to the n plus 1 times ln of 3 to the n over n cubed. So how we can simplify this a little bit? Well, we know that natural log of 3 here to the n and natural log of 3 to the n plus 1 is just a difference of ln of 3. So we can cancel this out and cancel this out. So we are left with limit as n approaches infinity, 1 over ln of 3, remember that is just a constant term, times n plus 1 over n. Well, we can group the cube term together. So moving this term outside the limit, we just have a limit as n approaches infinity of n plus 1 over n cubed. And from before, we know that this term equals 1 plus 1 over n. So this limit equals 1 over ln of 3 times 1. So we have 1 over ln of 3, which equals approximately 0.91. So 0.91 here is less than 1, which is the value of our L. Therefore, our series converges. So the ratio test here is very straightforward. We just plug in our original series with n plus 1 term instead of n and multiply it by itself, flipped with the denominator and the numerator. So in other words, dividing it. So writing it in the multiplication way makes everything much easier to see and much easier to be simplified. So that was an overview of the ratio test, which makes up the big chunk of our BC exam convergence tests of series. So thanks for watching Educator.com. We will see you in the next